Hello my dear students, let us take one more example on T section. Let us take this example. A 3 meter long cantilever with the T section is subjected to UDL of magnitude W through its length. The sizes of flange and web are 80 mm by 10 mm and 10 mm by 140 mm respectively. Taking allowable shear stress for the cantilever material as 30 MPa, find the magnitude or determine the magnitude of maximum UDL that can be applied. Here this is same thing here also asked to find the intensity of UDL, but here this beam is cantilever beam. So we know when the cantilever beam it is subjected to UDL, what is the formula? Shear force is equal to WL. Okay. And that is maximum shear force. Now here T section it is given 80 flange is 80 mm and 10. This is the flange 80 and 10 mm. And web is 10 mm and 140. So web is 10, width is 10 and height is 140 mm. Okay. Now first thing we have to calculate what is I. What is for to calculate I we required what is Y bar. Why? Because in the T section also maximum shear stress will be induced at the neutral axis. So at the neutral axis tau maximum is given by this equation, F into A Y bar divided by IB. For this we required F is equal to WL and A Y bar, that we have to calculate like how it is for I section. Same thing here also, that is moment of flange area about neutral axis plus moment of web area about the neutral axis about neutral axis. So that is A Y bar and I is the moment of inertia, B is width of the web. Okay, so one by one we will calculate. So this is a T section. First thing we have to calculate what is the position of the neutral axis. Okay, so let us assume anywhere on top or bottom. So I usually in the last problems considered at the bottom. Now in this problem let us consider at the top. Any side you can consider. Okay, if you consider at the bottom, whatever the answer you get, that is YB. If you consider neutral axis at the top, whatever the answer you get, that is YT. Now I consider neutral axis is at the on top layer. Okay, so what is YT? A1 Y1 plus A2 Y2 divided by A1 plus A2. So what is A1 Y1? Let us take this as 1 and okay, this is one section, this is 1 and this is 2. Okay, this is 2. So what is 1? 80 into 10. 80 into 10 into Y1. Y1. What is Y1? Distance from the neutral axis to the CG, or distance from the CG of that section to the neutral axis. Now my neutral axis is here. So distance from here to here. What is that distance? That is Y. So that is 10 divided by 2, 5. So 80 into 10, that is area, into 5, that is Y. Okay, distance from here to here. Next, for the second section, what is area? 140 into 10 into distance from the CG to the neutral axis. Now assume neutral axis is at the top. So distance from here to here, what is that? CG of this is 140, so total 140. So here to here this is 70 plus this 10, 80. Distance from the neutral axis to the CG. So CG is here, so here to here that is 70. 70 plus 10, that is 80 divided by A1 plus A2. A1 is 80 into 10 plus A2 is 140 into 10. So you get 52.7 mm. So for simplification we can take it as 53. So this is from the top because I considered neutral axis at the top. Now what is YB? So overall distance is 140 plus 10, that is 150. 150 minus 52.7, that is 97.3 mm. So you can take it as 97. Okay. So yt is 53 and yb is 97. Now you know the position of the actual neutral axis, that is 53 from the top and 97 from the bottom. This is the position of the actual neutral axis. Now we will calculate I. What is I? That is summation of BD cube divided by 12 plus AY square. This is, I have explained in the last chapters also how to calculate I for T section, that is BD cube divided by 12 plus AY square. Here there are two sections, so B1 D1 cube divided by 12 plus A1 Y1 square. Okay, let us calculate for the first section now here. What is BD cube by 12? B is 80, D is 10. 10 cube divided by 12 plus area is 80 into 10 into y square. Y is what? Distance from the CG to the neutral axis. Where is CG of this position? That is at a distance of y. So now the position of the neutral axis is here. So distance from here to here, that is y1. Okay, so what is that? Either you can write 53 minus 5 whole square, or this is total 53, so this is 10, so this distance is only 43 here to here, that is 43, so 43 plus 5, that also you can consider, or 53 minus 5, because y1 is distance from the CG to the neutral axis. Now neutral axis is here, distance from here to here is 53 minus 5. Okay, whole square, plus second section, B is now 10 and D is 140. So 140 cube divided by 12 plus A is 140 into 10 into, now CG is here, so distance from CG to the neutral axis, that is this distance, that is y2. Okay, so this is y2. What is this distance? See, distance from here to here, total this is from here to here 97. 97 minus CG. CG lies at a distance of 140 divided by 2, that is 70. So 97 minus 10, that is this distance. Okay, so full this is 97. CG lies at a distance of 70. So 97 minus 70 whole square. So you get I is equal to 5.157 into 10 raised to 6 mm raised to 4. Okay, now you can calculate what is maximum. You can use that formula, tau maximum shear stress at the neutral axis, that is tau maximum is equal to F into AY bar divided by IB. So F we know, I we calculated, B is width of the web that we know, and AY bar is moment of flange area about the neutral axis, this area, plus moment of web area about the neutral axis, What is the first one here? That is flange area. Now moment of flange area I have to calculate, that is 80 into 10 into y bar. Moment of flange area, so that is nothing but y bar. What is that? So here to here, that is 53, distance from CG to the neutral axis, that is 53.5 minus 5. Same thing here, whatever written here, that one only here also y bar, but formula is just AY bar, plus second one is web area. Now what is the web area above the neutral axis? Is only this portion, that is total this is 53, so this point is 43. So 43 into 10, that is this thickness of the web is 10. So this into this, that is total 53 minus 10, that gives this distance. So that is 43 into 10 into y bar. What is y bar? Distance from this is CG. CG is lies now here to here, neutral axis. CG is here. What is that CG? This portion is 43 now. So 43 divided by 2. That is the distance from here to here, y bar. Okay. So divided by 2, you get, when you simplify, 47,645. Now substitute in this equation Okay, so you get tau maximum, that is given here. Tau maximum is equal to 30 MPa. So 30 is equal to F into AY bar, that is 47645 divided by I. I is 5.157 into 10 raised to 6 into B, width of the web, that is 10. So you get F is equal to 32.47. Now Newton. Now we want W, not shear force. So what is shear force for the cantilever beam when the UDL is entirely loaded? Then F is equal to W into L. So what is F? F is 32.47 is equal to W into L. What is L? L is equal to 3 meter. The length of the beam is 3 meter. So into 3 you get 10.82 kilonewton per meter. Okay, so like this, in this way you can calculate W for the different sections. So now I taught how to calculate W for rectangular section, T section and I section. Only thing you have to take care of what is maximum bending moment, what is maximum shear force, and where it will be induced. And if it is for I section and T section, you have to calculate AY bar. Once if you know all the terms, you can apply the formula, that is tau maximum is equal to F into AY bar divided by I into B. So you will get the answer. I hope all of you understood. Thank you.